Welcome back to my series of videos walking through the SonicPy tutorial. In this video, section 5.5, Functions. Functions. Once you start writing lots of code, you may wish to find a way to organize and structure things to make them tidier and easier to understand. Functions are a very powerful way to do this. They give us the ability to name a bunch of code. Let's take a look. Oh, we're using foo. That's fun. Anyway, define foo as do, play 50, sleep 1, play 55, sleep 2, end. Okay, and where are we going with this? Here we've defined a new function called foo. We do this with our old friend the do end block and the magic word define followed by the name we wish to give to our function. We didn't have to call it foo. We could have called it anything we want, such as bar, baz, or ideally something meaningful to you like main section or lead riff. Remember to prepend a colon to the name of your function when you define it. Calling functions. Once we have defined our function, we can call it just by writing its name. We have define foo, do play 50, sleep 1, play 55, sleep 0.5 end, just like we have up here. And let's do foo, sleep 1, 2 dot times do foo end. Let's give that a listen. Okay, that makes sense. That's good. We can even use foo inside iteration blocks or anywhere we may have written play or sample. This gives us a great way to express ourselves and to create new meaningful words for use in our compositions. Neat. Functions are remembered across runs. So far, every time you've pressed the run button, SonicPy has started from a completely blank slate. It knows nothing except for what is in the buffer. You can't reference code in another buffer or another thread. However, functions change that. When you define a function, SonicPy remembers it. Let's try it. Delete all the code in your buffer and replace it with foo. Press the run button and hear your function play. Where did the code go? How did SonicPy know what to play? SonicPy just remembered your function, so even after you deleted it from the buffer, it remembered what you had typed. This behavior only works with functions created using define and def once, defonts. Well, I don't know what that is. Presumably we'll find out later. Parameterized functions. You might be interested in knowing that, like you can pass min and max values to rand, you can teach your functions to accept arguments. Let's take a look. Define my player do n play n end. My player argument 80, sleep 0.5, my player argument 90. This isn't very exciting, but it illustrates the point. Let's listen to it. This is supposed to be called my player. Sorry. Okay, try that again. Okay. Again, this isn't very exciting, but it illustrates the point. We've created our own version of play called myPlayer, which is parameterized. The parameters need to go after the do of the define block. Excuse me. The parameters need to go after the do of the defined do end block, surrounded by vertical goalposts, that's those, and separated by commas. You may use any words you want for the parameter names. The magic happens inside the define do end block. You may use the parameter names as if they were real values. Just like we used n here, as though it were, for example, 80 or 90. It's n. In this example, I'm playing note n. You can consider the parameters as a kind of promise that when the code runs, they will be replaced with actual values. You can do this by passing a parameter to the function when you call it. I would say passing an argument to the function when you call it, but okay. I do this with my player 80 to play the note 80. Inside the function definition, n is now replaced with 80, so play n turns into play 80. When I call it again with my player 90, n is now replaced with 90, so play n turns into play 90. Let's see a more interesting example. Define chord player, okay, do root repeats dot times do play chord at root with minor release 0.3 sleep 0.5 and chord player E3 2 sleep 0.5. Let's just check if it's working so far. Okay. Chord player A3 3 chord player G3 4 sleep 0.5 E3 3. Alright, let's give that a run. Run. That's kind of fun. Here I used repeats as if it was a number in the line repeats.do. I also used root as if it were a note name in my call to play. So let's look at that. We got repeats. Repeats is a parameter here, and it acts as a number here. Root is a parameter here, and it acts as a number here. See how we're able to write something very expressive and easy to read by moving a lot of our logic into a function. Yeah. All right, thanks for watching.